So better uses of the normal distribution, okay? Yesterday, we talked about the empirical rule. So if we were exactly 1 standard deviation away, or 2 standard deviations away, or 3 standard deviations away, we were able to get about how much of the data should be within those, right? Excuse me. Oh. All right, so today I'd like to get rid of these numbers. These numbers are good. They turn out to be nice standard deviations, but there's a lot of deviations between 1 and 2 and between 0 and 1. And so this little piece of paper that I handed out to you, it's got all of those deviations. It's got all those different percentages on there. Isn't it beautiful? Mm-hmm. Sure is. All right, so today what we're going to do is we're just going to find a spot that is a random number of deviations from this center right here. Call it X. It's still going to be a z-score. A couple things that we need to know. Remember, this is a probability distribution, so that all the area underneath this curve is still going to be 1. Keep that in mind. That's going to help us. So if the area to the left is given, I can just take 1 minus, and I can get the area that's to the right. So what we're going to run into is we're still going to run into that greater than or less than that we had on the last test. And we still have the horizontal asymptote working as, the horizontal axis working as a vertical asymptote. Meaning it looks like the probability is coming down and getting really close to 0 down here, but it never actually touches 0. Okay, so keep that in mind as well while we work this, because I'm gonna have to talk about that on some of these examples. That's it. That's all I got. Any questions? All right, let's sit. Go back, yeah. Yeah, that equation looks kind of funny. We'll talk about it. All right, so I'll work one example with you. I'm going to let you do one with your buddies. So the final exam score in statistics, or I guess in a statistics class, was normally distributed with a mean of 63 and a standard deviation of 6. See, that's not you guys, because you guys are going to score way higher on the final exam in here, correct? Yeah. Yes. All right. So what I want to do, I want to find the probability that if I select a random student that they scored less than a 70. Now again, I'm going to urge you, you're going to want to do a curve on all of these, a normal curve. What's right in the middle of this normal curve? What is it? The mean, which is 63. Good. 63 is right here in the middle. And here's the problem we're going to run into today: is the standard deviation is going to be 6. Meaning if I go up 6, I should land at 69. That's not 70. All right, I want less than 70, but I want to also take into account someone that scored maybe a 69.5 and so forth. So you're going to see numbers that might be similar to yesterday, but also a good point, Brittany. I do want to go over to a 70 right here, but I want all the people that scored less than 70. Okay, which yesterday I just had people that were within 1 or 2 or 3 standard deviations. You guys ready? There's 2 ways to tackle this. I'm going to show you 2 ways. And every year it's about 50-50. 50% of people like one way, 50% like the other way. So for part A right here, what I'm going to do is I'm going to find a z-score. We're finding a z-score. I'm just taking the number I'm interested in, 70, subtracting off the mean, and dividing by the standard deviation. We're going to find that we're pretty close to 1 standard deviation away, but we're going to be a little bit off. What is it? 1.16. Two decimal places is good. Repeating, so 1.17. Once you find your z-score, your answer is on this chart that I passed out in front of you. Keep in mind 1.17. Right? Is it here? Yeah. All I need to do is find my z-score of 1.17 on here, and it tells me the area that's to the left. As you can see, they're reminding you, hey, all of these areas are to the left. So what we're going to do is we're going to go in the left column. Yours is all one sheet. Looks a little bit different than mine. But I'm going to start in this left column right here, and I'm just going to go down until I find 1.1. That would be this line, correct? 1.1, and as I work my way across, it's telling me what the second decimal place is across the top right here. 0.7, 1.17. So if I find where these two meet, 0.879. And that's my answer. There is a way in the calculator, but this way is pretty easy. All right, so let's go back. We're able to answer the first question. Find the probability. It would just be 0.879. 87.9% chance that if I randomly select a student, that they scored less than a 70 on it. Not too bad, is it?
I mean, no, that's terrible.
It's terrible? Oh.
Going less than a 70?
I know, that's why I said it's not this class. I need to change the number so it sounds more promising. What about more than a 65? It's going to be a little bit different on this. I still have, what's my middle number, 63? That's a 65. Let's do 63. More than a 65. Where would a 65 be at on this bell curve? It's just barely to the right. About here. Now, on this bell curve, am I wanting the right side of the line or the left side? Right side, because more. All these people over here scored more. Did I just shade more than 50% or less than 50% of the curve? Less. So I expect my answer to be less than 50%. Less than 50% of the students scored more than 65% or a 65. Maybe it was only out of like 80 points. That's what we could say. That's it. That's it. All right, so I need a z-score for this. I got to find a z-score each time. What's my z-score? 2 decimal places. 0.33. .33. So on your table, let's find that z-score for 0.33. .33. So we're on this line and this column. 0.6293. What happened? Why would I subtract it from 1? Because look, this chart doesn't know whether I'm working with the left side or the right side. That's why I drew my picture. This chart thinks I'm working with the left side every time. Okay? So what they told me was that this area right here was 0.6293. So remember, all the area underneath this curve is going to be 1. So how much does that leave for this gap right here? 0.3707. 0.3707. 37% chance that someone scored over a 65 on this exam.
So our quiz will be here,
Yeah, no, you need to memorize those, and I'll. You'll get to use it. You will just use that one. So don't throw any other formulas on there, but pencil marks. And then that's going to be straight pencil marks. Going to be fine. If you need another one, there should be some extras. So I'll make some more copies of those. So if you do lose it, I can put one on there. All right, now on your project Monday, it will expect you to do that. All right, it'll expect you to find different values on this sheet. All right, we're going to do our own project. We're going to be collecting data. You're going to have to see if it's normally distributed. I hope that it is. A couple times it hasn't been in the past, but I can force it to be normally distributed if I need to. So let's try one this way. It says find the 90th percentile. In case you forgot what percentile is, remember I'm telling you, that means I want to find the score that someone made where they scored 90% better than everybody else. All right. Hold on, let's draw ourselves a picture. Where's the 90th percentile at? No, because okay, we're getting this confused with what we did yesterday. It's correct to say that 95% of the data will be between two standard deviations. Okay, but we're not basing things off the middle so much today. Okay, so what you need to think about is 90% will mean that 90% of the data is over here and only 10% of the data is over here, correct? Someone that scored in the 90th percentile is going to be way over here in this right tail, where they scored better than 90% of the population that took this exam. Does that make sense? So I'm working it backwards. I want to know what this score right here is. They've been telling me the score, and I can find the z-score. So what I have to do is I have to go find the z-score myself. Not 90, because that would mean I'm 90 standard deviations away. What I'm going to look up is I'm going to say, okay, this 0.9 right here, what z-score did this line land on? How many standard deviations away from the middle is the 90th percentile? So I just have to use my table backwards. What does that mean? What's the bald guy talking about using it backwards? That means I get to look at all of these fun numbers and I have to find the closest one to 90%.
I think it's 1.3.
1.3? 1.3 is right here. I can get closer, ma'am. 1.29 is right here. I can get closer, sir. 1.28. Look how close that is to 90%. 0.8997 on my chart. Is that the same on yours? I hope so. Hopefully there's not multiple of these charts going around. All right, so 1.28. That's how many standard deviations I am away from the mean for someone that scored in the 90th percentile. All right, so 1.28. Let me go back and write that down. So for this z, I'm going to put in a 1.28. That's my z-score for someone that scored in the 90th percentile. Remember, I'm trying to get my hands on x right here. Do I know what mu is? It's the mean, 63. All right. Do I know what the sigma is? 6. It's my standard deviation. Can we solve that for x?
Yeah.
We did that a couple nights ago on the homework. All right. So help me out with that. Solve that for x.
Multiply 6 by
Multiply both sides by 6. That's 7.68. And then add 63, so 70.68. So someone that scores a 70.68 on the final exam did better than 90% of their peers that took the same test.
Man, that's tough.
Now the test was only out of 71, so they did pretty good. All right.
Wait a minute. I feel like someone scored higher than that earlier.
Does that make sense? Let's do it one more time. Okay, go to your chart and find me the 70th percentile. We'll work part D together. Okay, I draw myself a bell curve every time to help myself make sense of what's going on. So find the 70th percentile on your chart. What is it? 0.52? Anybody verify that? That's the closest thing to 70%? 0.53. 0.52, okay. So that goes in for my z-score. And then my math is the exact same. The only thing that changed on this is going to be my z-score or my x. My mu is going to stay the same, and my sigma is going to stay the same. So I expect this score to be a little bit lower than the 90th percentile because I only had to score better than 70% of the people that took the test. What is it? 66 point what? 12? Someone scored a 66 on this, did better than 70% of their peers. Yeah, the test was out of 71 points. They're doing well. This is a very smart class. Okay.
I was at 94.
Hey, that's pretty good.
Yeah, let's do the race all.
Thank you. Be here all year, hopefully. All right, so you and your table buddy work this one with your Z table. All right. If you're watching this video, I'm going to hit pause on it while we work it, and then you can come back and see if you match our answers.
See ya.